Hello and welcome back to the channel. In today's video I'm overclocking the Radeon 740M integrated in the Ryzen 5 8500GE all the way up to 3.3 GHz using the ASUS ROG Crosshair X670E Hero motherboard and custom loop water cooling. I already overclocked the CPU cores of this APU in SkatterBencher number 74. But today we get to do what's arguably the most exciting part of APU overclocking. Overclocking the integrated graphics. And we'll also dig a little bit into memory timing tuning. Alright, let's get started. The Radeon 740M is not a new product for AMD, as it was also available in some 2023 Phoenix notebook processors. The Radeon 740M is only available on the desktop with the Ryzen 5 8500G and GE and Ryzen 3 8300G and GE APUs. The Ryzen 5 8500GE is one of the Phoenix 2 based Ryzen 8000 desktop APUs, codenamed Hawkpoint. Hawkpoint is the successor to the Ryzen 5000 Cezanne APUs launched in 2021. I already overclocked a couple of Hawkpoint APUs on this channel, including the Ryzen 7 8700G and the Ryzen 5 8600G, and I also overclocked both of those APUs their integrated graphics. With the Radeon 700M integrated graphics, AMD finally brought the RDNA 3.0 architecture to the desktop, as the integrated graphics for the Ryzen 7000 processors was still the RDNA 2 architecture. AMD announced the RDNA 3 graphics architecture on November 4, 2022 during their Together We Advance gaming event. About a month later, the first RDNA 3 products entered the market with the Radeon RX 7900 XT and XTX featuring the Navi 31 chiplet. The Radeon 740M has two workgroup processors, or WGPs, with 4 compute units, CUs, and 4 array accelerators. The maximum GPU frequency is 2.8 GHz, the TDP is 35 Watt, and the TJ Max is 95 degrees Celsius. In this video, we will cover 5 different overclocking strategies. However, before we jump into the overclocking, let's first have a look at the hardware and the benchmarks that we'll be using in this guide. The system we're overclocking today consists of the following hardware. In March 2023, I launched the EFC SkatterBencher edition in collaboration with Elmo Labs. The EFC SB is a customized version of the original Elmo Labs Easy Fan controller. The base product functions and features are the same as the original EFC, with a tiny improvement here and there. I explain how I use the EFC devices in many previous SkatterBencher guides. I monitor the ambient temperature, water temperature, and fan duty cycle, and I also use the device to map the radiator fan curve to the water temperature. I use this configuration for all overclocking strategies. The main takeaway from this configuration is that it gives us a good indicator of whether or not our cooling solution is saturated. We use Windows 11 and the following benchmark applications to measure performance and ensure system stability. Before we start overclocking, we first have to check the performance at default settings. The default Precision Boost 2 parameters for the Radeon 740M are as follows. Here is the benchmark performance at stock. When running the 3DMark Speedway stability test, the average GPU effective clock is 2807 MHz with 1.023 volts. The GPU memory clock is 2400 MHz. The average GPU ASIC power is 32.8 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 2646 MHz with 1.109 volts. The GPU memory clock is 2400 MHz. The average GPU ASIC power is 41 watts. In our first overclocking strategy, we simply leverage enabling Precision Boost Overdrive and AMD EXPO. AMD Precision Boost Overdrive 2 is AMD's proprietary overclocking toolkit, which allows end users like you and I to fine-tune the CPU and APU performance. It's mostly used to tune the CPU performance, but it also has some tools to improve the graphics performance. With the launch of Zen 3, AMD introduced an improved version of the Precision Boost Overdrive toolkit, allowing for manual tuning of even more parameters affecting the Precision Boost frequency boosting algorithm. Precision Boost Overdrive 2 builds on the PBO implementation of Zen 2. In addition to the overclocking knobs from Zen Plus, PPT, TDC and EDC, and Zen 2, Boost Override and Scalar, Precision Boost Overdrive 2 also introduced Curve Optimizer. There are essentially 3 levels of Precision Boost Overdrive. By enabling Precision Boost Overdrive, we rely on the motherboard pre-programmed PBO parameters. We find that the following values have changed. Increasing the PPT and to a lesser extent the TDC and EDC limit will help unleash the frequency in extreme workloads previously limited by the power limits. Unlocking the power can really make this little APU scream, especially in maybe somewhat unrealistic workloads where both the CPU cores and the GPU are loaded 100%. An easy way to test this case is by using the OCCT power test. Here you can see the APU run at over 115 watts. That's more than 3 times the rated TDP. AMD EXPO stands for AMD Extended Profiles for Overclocking, and it's an AMD technology that enables ubiquitous memory overclocking on AMD platforms that support DDR5 memory. Essentially, it allows memory vendors such as G.Skill to program higher performance settings onto the memory sticks. And if your motherboard supports EXPO, then you can enable that higher performance with the click of a single button in the BIOS. As we'll see later in the video, unlocking memory performance is critical to improving APU graphics performance. Upon entering the BIOS, switch to the Extreme Tweaker menu. Set AI Overclock Tuner to EXPO 1. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Enabled. Then save and exit the BIOS. We rerun the benchmarks and check the performance increase compared to the default operation. Unlocking the power limits and enabling higher memory performance substantially improves the integrated graphics performance. The geomean performance improvement is plus 5.80%. When running the 3DMark Speedway stability test, the average GPU effective clock is 2812 MHz with 1.033 volts. The GPU memory clock is 3200 MHz. The average GPU ASIC power is 44.6 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 2819 MHz with 1.047 volts. The GPU memory clock is 3200 MHz. The average GPU ASIC power is 59.3 watts. In our second overclocking strategy, we use the Precision Boost Overdrive 2 toolkit to improve the graphics clock frequency. Fused Maximum Frequency, or Fmax, is one of the Precision Boost infrastructure limiters constraining the performance of your APU. Essentially, it dictates the maximum allowed frequency of either your CPU cores or your graphics. GPU Boost Clock Override, or GPU Fmax Override, is one of the overclocking tools available in the PBO2 toolkit. It allows the user to override the arbitrary clock frequency limit up to plus 200 MHz in steps of 25 MHz. It's important to note that the GPU Boost Clock Override only extends the upper ceiling of the graphics curve. It doesn't act as an offset. When we increase the GPU Fmax boost limit by 200 MHz, the new GPU Boost Fmax is 3 GHz. On AMD Hawkpoint processors, the memory subsystem consists of 3 important parts: the Infinity Fabric, the Unified Memory Controller, and the System Memory. These are more commonly referred to as the F-clock, the U-clock, and the M-clock. First generation Ryzen overclockers know that these parts used to be tightly coupled together, but on modern Ryzen processors like the Ryzen 5 8500GE, we can tune them independently. There are 2 things I wanted to address with memory subsystem performance improvement. First, I wanted to fix the downclocking of the F-clock and U-clock, and second, I wanted to run the U-clock and M-clock in sync. To solve the first problem, we simply enable SoC on Core OC mode in the AMD overclocking submenu. To address the second problem, we simply set uClock div1 mode to uClock equals memclock. The memory controller frequency is tied directly to the system memory frequency. It can run either at the same or half its frequency. We run the memory controller frequency in sync with the system memory for this OC strategy. At DDR5 6400, the memory controller frequency is then 3200 MHz. EXPO tweaked is one of the options available under the AI Overclock Tuner option in the ROG BIOS, in addition to EXPO 1 and EXPO 2. All three settings load the memory kit EXPO profile, but do so slightly differently. Since memory performance may impact our benchmark performance, I tried the EXPO tweaked setting. Everything seemed stable, so I used it for this OC strategy. Upon entering the BIOS, switch to the Extreme Tweaker menu. Set AI Overclock Tuner to EXPO Tweaked. Go to the Advanced menu. Enter the AMD Overclocking submenu and click Accept. Enter the DDR and Infinity Fabric Frequency Timings submenu. Enter the Infinity Fabric Frequency and Dividers submenu. Set uClock div1 mode to uClock equals memclock. Leave the Infinity Fabric Frequency and Dividers submenu. Leave the DDR and Infinity Fabric Frequency Timings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Advanced. Set PBO limit to Motherboard. Set GPU Boost Clock Override to Enabled. Set Max GPU Boost Clock Override to 200 MHz. Leave the Precision Boost Overdrive submenu. Enter the SoC on Core OC mode submenu. Set SoC on Core OC mode to Enabled, then save and exit the BIOS. We rerun the benchmarks and check the performance increase compared to the default operation. With only a slightly higher frequency of 200 MHz, we didn't expect much of a performance improvement. However, nothing is further from the truth and we get a pretty substantial performance uplift, perhaps due to the improved memory timings. Compared to the previous OC strategy, the geomean performance improved by 8 percentage points. When running the 3DMark Speedway stability test, the average GPU effective clock is 3003 MHz with 1.178 volts. The GPU memory clock is 3200 MHz. The average GPU ASIC power is 54.7 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 2996 MHz with 1.200 volts. The GPU memory clock is 3200 MHz. The average GPU ASIC power is 72.8 watts. In the third overclocking strategy, I'm going to manually set all the frequencies related to graphics performance. That includes the F clock, the M clock, the U clock, and the GFX clock. But before I show you my manual settings, let's first have a look at the Hawkpoint clocking and voltage topology. Understanding how clocking and voltage works will also help us better understand where the tuning opportunities lie. The clocking of Hawkpoint APUs is similar to other Zen 4 desktop processors. The standard Hawkpoint platform has a 48 MHz crystal input to the integrated CGPLL. The CGPLL then generates a 48 MHz clock for the USB PLL and a 100 MHz reference clock for the FCH, which contains the CCLK PLL for the CPU cores and several SoC PLLs. Each CCX has its own PLL, with the cores within that CCX running at the same frequency. The SoC PLLs include a wide range of PLLs present on the die. The ones most relevant for overclocking are the F clock, the U clock, the M clock, and the GFX clock. As per usual, the processor relies on an internal and external power supply to generate the processor voltages. There are 4 primary power supplies from the motherboard VRM to the processor. The VDD-CR voltage rail provides the external power for 3 internal voltage regulators: VDD-CR CPU, VDD-CR VDD-M, and VDD-CR GFX. The VDD-CR GFX provides the voltage for the integrated graphics. In the past, this voltage would be provided by the VDD-CR SoC voltage rail. It's likely due to the high current requirements of the powerful integrated graphics. Using the typically beefier VDD-CR voltage plane is safer. The voltage rail can technically work in regular or bypass mode, but only regular mode is available. In regular mode, the voltage is managed by the integrated voltage regulator and derived from the VDD-CR voltage rail. The voltage is limited to 1.2 volt due to the presence of Zen 4C cores on this APU. Manual overclocking of the Radeon 740M is pretty straightforward. It's a trial and error process. For example, for the F-clock, I could successfully increase the frequency to 2600 MHz. Overclocking the memory and memory controller are tied together. In my case, I could run them in sync up to DDR5 6600. The graphics overclocking process was much more enjoyable than with the previous two Phoenix IGPs I've tried. I could increase the graphics frequency to 3300 MHz in our worst case stress test. I could further increase the frequency to 3400 MHz in lighter workloads like 3D Mark Speedway. Upon entering the BIOS, switch to the Extreme Tweaker menu. Set AI Overclock Tuner to EXPO Tweaked. Set memory frequency to DDR5 6600. Go to the Advanced menu. Enter the AMD Overclocking submenu and click Accept. Enter the Manual iGPU Overclocking submenu. Set GFX clock frequency to 3300. Set GFX voltage to 1200. Leave the Manual iGPU Overclocking submenu. Enter the DDR and Infinity Fabric Frequency Timings submenu. Enter the Infinity Fabric Frequency and Dividers submenu. Set Infinity Fabric Frequency and Dividers to 2600. Set uClock div1 mode to uClock equals memclock. Leave the Infinity Fabric Frequency and Dividers submenu. Leave the DDR and Infinity Fabric Frequency Timings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Advanced. Set PBO limits to Motherboard. Leave the Precision Boost Overdrive submenu. Enter the SoC Uncore OC mode submenu. Set SoC Uncore OC mode to Enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. Tuning every aspect of the graphics performance gives us another significant performance uplift across all benchmarks. Compared to the previous OC strategy, the geo-mean performance improved by 8.6 percentage points. When running the 3D Mark Speedway stability test, the average GPU effective clock is 3292 MHz with 1.2 volts. The GPU memory clock is 3300 MHz. The average GPU ASIC power is 58.7 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 3290 MHz with 1.2 volts. The GPU memory clock is 3300 MHz. The average GPU ASIC power is 77 watts. In the fourth overclocking strategy, we will try to optimize the graphics performance by tuning the memory timings. On this ROG Crosshair X670E Hero motherboard, a very easy way to get that done is by leveraging the ASUS memory presets. ASUS memory presets is an ASUS overclocking technology that provides you with essentially a list of pre-tuned presets for certain memory ICs. It will adjust the memory timings and the voltage. The technology was first introduced in 2012 on Z77 and has been on select ASUS ROG motherboards ever since. The memory profiles available differ from platform to platform. On the ROG Crosshair X670E Hero motherboard, we find 14 memory profiles for a variety of memory ICs and configurations. Since we already increased the memory frequency to DDR5 6600, we just want to use the presets for memory subtimings tuning. In this case, we use the Hynix 6400 1.4 volt 2x16GB single rank preset. For the most part, these memory timings work without any issue, as I can pass the OCCT memory stress test. However, I do get green flashes when entering the operating system. To make a long journey of testing every memory timing to find the culprit short, turns out the TRAS timing has to be relaxed to avoid the green flashes. Upon entering the BIOS, switch to the Extreme Tweaker menu. Set AI Overclock Tuner to EXPO Tweaked. Set memory frequency to DDR5 6600. Enter the DRAM timing control submenu. Enter the memory presets submenu. Select Load Hynix 6400 MHz 1.4 volt 2x16GB SR and click OK. Leave the memory presets submenu. Set TRAS to 38. Go to the Advanced menu. Enter the AMD Overclocking submenu and click Accept. Enter the Manual iGPU Overclocking submenu. Set GFX clock frequency to 3300. Set GFX voltage to 1200. Leave the Manual iGPU Overclocking submenu. Enter the DDR and Infinity Fabric Frequency Timings submenu. Enter the Infinity Fabric Frequency and Dividers submenu. Set Infinity Fabric Frequency and Dividers to 2600. Set uClock div1 mode to uClock equals memclock. Leave the Infinity Fabric Frequency and Dividers submenu. Leave the DDR and Infinity Fabric Frequency Timings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Advanced. Set PBO limits to Motherboard. Leave the Precision Boost Overdrive submenu. Enter the SoC on Core OC mode submenu. Set SoC on Core OC mode to Enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. To my surprise, tuning the memory timings still has quite a significant impact on the benchmark performance despite this iGPU being relatively weak. It provides us with a 4.3 percentage point geomean performance improvement over the previous overclocking strategy. When running the 3DMark Speedway stability test, the average GPU effective clock is 3292 MHz with 1.2 volts. The GPU memory clock is 3300 MHz. The average GPU ASIC power is 58.5 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 3290 MHz with 1.2 volts. The GPU memory clock is 3300 MHz. The average GPU ASIC power is 76.1 watts. In the fifth overclocking strategy, I want to see the same huge performance improvement as we saw with the Radeon 780M and Radeon 760M in SkatterBenchers number 70 and 73. So just like in those guides, I swap out my EXPO 6400 kit for an XMP 7800 kit. As a tuning starting point, I once again turn to the ASUS memory presets, and this time we load the Hynix 7600 2x16GB preset. Similar to the previous overclocking strategy, we have to adjust the TRAS timing to get rid of the green flashes. I did have a closer look at memory performance scaling. As I mentioned before, tuning the memory timings can have quite a big impact on the memory performance. And when we have a closer look at the memory scaling, we can clearly see why. We can surpass the 3D performance of an untuned XMP 7800 kit with a well-tuned EXPO 6400 kit. Furthermore, it is more clear now what's driving the performance gains as the memory copy bandwidth correlates strongest with 3D performance. Anyway, now that we know how to tune our XMP kit, let's go into the BIOS. Upon entering the BIOS, switch to the Extreme Tweaker menu. Set AI Overclock Tuner to DOCP1. Enter the DRAM Timing Control submenu. Enter the Memory Presets submenu. Select Load Hynix 7600 MHz 1.45 volt 2x16GB single rank and click OK. Leave the Memory Presets submenu. Set TRAS to 46. Leave the DRAM Timing Control submenu. Go to the Advanced menu. Enter the AMD Overclocking submenu and click Accept. Enter the Manual iGPU Overclocking submenu. Set GFX clock frequency to 3300. Set GFX voltage to 1200. Leave the Manual iGPU Overclocking submenu. Enter the DDR and Infinity Fabric Frequency Timings submenu. Enter the Infinity Fabric Frequency and Dividers submenu. Set Infinity Fabric Frequency and Dividers to 2600. Set uClock div1 mode to uClock equals memclock. Leave the Infinity Fabric Frequency and Dividers submenu. Leave the DDR and Infinity Fabric Frequency Timings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Advanced. Set PBO limits to Motherboard. Leave the Precision Boost Overdrive submenu. Enter the SoC on Core OC mode submenu. Set SoC on Core OC mode to Enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. To my great surprise, the low-end RDNA 3 integrated graphics keeps scaling with increased memory performance. Compared to the previous OC strategy, the geomean performance improved by nearly 6 percentage points. When running the 3DMark Speedway stability test, the average GPU effective clock is 3292 MHz with 1.2 volts. The GPU memory clock is 3900 MHz. The average GPU ASIC power is 61.7 watts. When running the OCCT 3D standard stress test, the average GPU effective clock is 3288 MHz with 1.2 volts. The GPU memory clock is 3900 MHz. The average GPU ASIC power is 78.4 watts. Alright, let's wrap this up. The Radeon 740M is the weakest of all 3 Hawkpoint APU integrated graphics. Still, it seems that by overclocking the graphics and the F-clock, the U-clock and the M-clock, we can improve the performance quite significantly. However, not as much as we could do with the 780M and the 760M. That said, the Radeon 740M overclocking experience was a little bit better than those 2 other IGPs. I could reach higher frequencies with less voltage. And I was also surprised that even though this iGPU is pretty weak, memory scaling still had quite a big impact on the overall performance. Anyway, that's it for me. This is probably the final Hawkpoint integrated graphics video that I'm making, since the Ryzen 3 IGP is also the Radeon 740M. And I'm kind of looking forward to trying something else. I want to thank you for watching and the patrons for the support. If you have any questions or comments, drop them in the comments section below. I'll also put a written version of this video on my blog if you want to read through the BIOS settings or check my performance results. And that's it. See you next time.